Let's take a couple minutes and talk about energy and more specifically how energy relates to motion in physics. So, work is the transfer of energy by mechanical means. And energy is transferred through motion. And which that says that there's some sort of energy transformation that goes on when an object is moving. And there's two types of energy. There's kinetic energy and there's potential energy. So as an object moves, the energy transfers between kinetic energy and potential energy. And we're going to talk about each one of those and how there is an energy transformation between kinetic energy and potential energy in the realm of motion. So, kinetic energy. Kinetic energy is any time an object is in motion. And we measure kinetic energy in joules. And a change in kinetic energy of an object is equal to the net work done on it. So all the work done on an object is equal to the kinetic energy of that object. And the faster an object moves, the more kinetic energy it has. So the equation that we have is kinetic energy equals 1/2 mv squared. Don't forget to square your velocity. So as velocity goes up, the more kinetic energy we have. Also, as mass goes up, there's more kinetic energy. And then there's also potential energy. This is energy stored in an object because its state or position. So as an object is higher or placed higher above the ground, it has more potential energy. So if you have something sitting on a table and something sitting on top of a building, the object that is sitting on top of the building has more potential energy than the object sitting on the table because it is higher off the ground. And typically we measure the height of these objects from either the Earth's surface or the surface of the floor in a room. So that is how we measure the height so we can get our potential energy. And there is also an equation for potential energy, which is mass times gravity times height. And so the higher the object is above the Earth's surface, the greater the potential energy. So let's talk about conservation of energy. There's a law of conservation of energy that says within a closed system or an isolated system, energy can change form, but the total amount of energy is constant. So the energy may turn from potential energy to kinetic energy, but as a whole, all the energy is still there. It's just either in potential energy form or kinetic energy form. So let's talk about this with someone who is going to take a high dive into a pool. So, if you're looking at the very top, whenever the person is standing at the very top of the high dive, they have 100% potential energy. They're not moving, they're just standing there, and so that says that all their energy is just potential energy. But they start to dive, so they first begin to fall off the high dive, and that shows that their potential energy begins to decrease because their height isn't as high, but that energy is transferred into kinetic energy. So the potential energy may drop a little, but the kinetic energy increases. So all the energy is still there, it's just part of it has transferred into kinetic energy form. And as the diver is halfway down, it is half potential energy and half kinetic energy. We still have 100% of the energy, but now it's split evenly between potential energy and kinetic energy. And whenever the diver first begins to enter the pool, they have used up all their potential energy, and now everything is kinetic energy. So the diver does not run out of potential energy until they begin to enter the pool. But until then, they still have a little bit of kinetic energy. But once they enter the pool, they are at 100% kinetic energy. So at any point during the dive, the potential energy and the kinetic energy will add up to 100% of the total original energy that the diver had when they were first standing at the top of the high dive.